Hello, everyone, and thank you for joining us for today's session. My name is Askia. I'm the facilities coordinator for the Redmond Reactor space. Before we start, I have a few things to go over, so please take a moment to read our code of conduct. Oops. Sorry about that. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. Useful links will be shared throughout the chat. The session is recorded and will be available on demand in 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. It will run for approximately 1 hour with time for questions throughout. So we'll now turn it over to our speakers.
All right, great. Thank you so much. Welcome, everybody, to this session. I'm Jasmine Greenaway. I am here joined with Joe Karlsson. And today we're going to be talking about data engineering. So I am quite new to the topic. Joe, are you there? You want to say hello to the audience before we get started?
Hey, I'm here.
Hey.
I've never gotten a double introduction before. This is great.
So we're here to chat about data engineering. So I was just sharing that, I'm quite new to the data engineering space. Just coming into a year. There's a lot to learn, and it's a whole wide world out there. What about your experience?
Yeah, I gotta say the same thing. I've been in the database space for I don't know, at least 5 years now. I still feel like I'm learning a lot, and the data space is always changing, just like the rest of tech. So it's just lots of new buzzwords floating around all the time. I don't know. I feel like I'm still learning it too, but that's good. I think that's good if we both feel like we're thrown in the deep end all the time. That means we're pushing ourselves, which is always good.
Yes.
I don't know. I'm new to it too. We're going to be going through one of my goofy side projects together today. That is, it's not particularly impressive from a technical perspective, but it's I want to show kind of how I've been learning data engineering and data science on my own. So anyway,
we're all new. Yeah, no, by the way, I really loved your demo. I think the crowd out there will be excited. Folks, any of you out there are new to data engineering, please share in the comments, share in the chat. Let us know what you're learning, even if it's not data engineering.
Yeah. So what type of databases you're playing with. What kind of projects with it? If you're working on a side project or something at work, I'd love to hear about it.
Yes, definitely. Great. So we'll go ahead and get started. I'm going to kick off. So essentially with data engineering, we're kind of taking this angle here where we're going to be talking about some tools that make you more productive as a data engineer using cloud technology. So we'll be talking about how to send your development environment to the cloud with GitHub Codespaces and how to manage your data and work with it in the data engineering space with Tinybird. So I will be covering GitHub Codespaces and Joe will be covering Tinybird. We'll see them a little later. Let's go ahead and get started. So let's intro GitHub Codespaces here. So moving along in my slides, let me just advance. So GitHub before, as I hinted before, it's development environment in the cloud. Essentially, you can it's an opportunity for you to collaborate with other developers, because one of the biggest challenges as someone who has a background in software engineering is setting up the development environment. We've all kind of, especially if you're in the industry yourself, you've probably heard stories about, it took me a week to get my development environment, set up. And, things like Codespaces are here to help you get a little bit more productive, a little bit faster, and try to alleviate some of the development environment headaches. So moving along here, Codespaces, it's essentially, again, a cloud-based development environment. And what that allows you to do is essentially code anywhere, code on any device, essentially that has an internet connection. So another great thing about it is that you can work with different types of editor. Of course, we are VS Code fans here, but you can use Jupyter Hub, or even JetBrains with the editor, terminal, debugger, version control, all the things and all the extensions that you use in the cloud. So you can use it, and again, any device in your browser, desktop, really just log in to GitHub and open your Codespace. And we'll see a little demo in a second here. Also, on top of that, again, you're only relying on your device as a vehicle for you to interact with your code base. So this is really great if like maybe you are working on a demo like I have and have some documentation. Maybe there's something like a typo in your documentation, and you need to fix it real quickly. I could just get on my phone and open it up in a Codespace and go ahead and fix that and push that all on my phone. Now, I guess I'm relying on my phone to make this edit, but the image that the development image or the development environment is in the cloud. So you're really relying on the cloud to execute your code, run your code. So things like notebooks and things like that. So remember, it's not on your local machine. It's in the cloud. So and also it's pretty fast. You can start up your Codespaces in really in seconds. That after that first initial loading, really quick. And a bunch of other things you can. So if you're already a VS Code fan like us, you can sync across extensions and across development environments. So you can also bring things like your doc files, which we will get into next. So why would you use it? So like I mentioned before, as I shared that story of taking a extended amount of time to get your development environment set up, not only in a work environment, but think about hackathons. You all have decided on a project and you all know the tools you're going to use, but everyone has to install, these things separately on a computer. Why don't you leverage the cloud so that you can easily get started and everybody can have the same development environment? And, things like hackathons, they usually are 24 to 48 hours, and it's a hectic time. But things like Codespaces can make this process easier so you can focus on what you're building versus how you're configuring how to get it done. As I mentioned before, these are some additional points here. Configurable for your needs. So you can essentially install, again, extensions, any other tools, things like command line, CLI tools, things like that. And again, use the things you know and love. So if you are somebody with things that you know and love that can fit into a doc file, you can actually apply your doc file to your Codespaces, so you can easily get your development environment that you're familiar with up and running. You can apply your doc file to pretty much any repository you own. So what do you get in a Codespace? You get with GitHub free personal accounts, you get 15 gigs of storage per month. And up to 120 core hours per month. So this is, 120 hours of development time in your environment for 15 gigs of storage per Codespace, or 15 gigs of storage per month in your entire Codespace. We'll talk a little bit about how to conserve those resources. But if you have a pro account, you can that goes up to 20 gigs of storage per month and 180 hours per month. So in addition to that, say that you need a little bit more compute power. So any of you data science fans out there, any data engineering fans or devs out there, if you need a little bit more compute power, we all know we all want a GPU. We all want things that help us do number crunching a lot faster. You can actually change your machine type. So by default, I believe it's 2 gigs of RAM, and you can go all the way up to 32, as well as apply for apply a GPU compute. And, just to keep in mind that these are some of these things might be a little bit pricey or essentially outside of that free range. Remember that, with 15 gigs of storage, 120 core hours per month, you're looking at 2 gigs of RAM, or essentially 2 cores. And then on top of resources, and as well as money, here are some tips just to conserve your resources. Make sure to stop your Codespaces if you're not using it. Remove anything that's inactive, again, that takes up space. Remember to pick the machine type you use, so that essentially that core and memory pair. Just be aware of what exactly you need, and then just be sure to track costs in your GitHub billing settings. You can find this under your settings in the top right hand corner when you click on your profile in GitHub. So all that to say is that it's ready for you to use right now if you haven't used it. If you have a repository right now, I won't be upset if you go and try to open your repository in a Codespace. And we'll take a look at how you can do that if you're new to the topic. But let's quickly walk through how it works. So when you create a Codespace, the first thing that's going to happen is that first you think about the source. Let's talk about the source. You can create a Codespace from a repository template, even a Git commit, or an open pull request. So if you're doing things like if you own an open source project and you need to review some PRs or pull requests that are coming in, you can do that with a Codespace. The next thing that happens is that a private virtual machine is created just for you. This is what essentially gives you that compute power. Moving along, then a container is created for your development environment. The next step there is that after that container is created and your development environment is created, this is the part where you would have some additional configuration setup. So things like anything that you would essentially put in a Docker file would run at this point. And we'll look at a little bit of the hierarchy there. And then finally, once it's all set up, then you're connected to a Codespace. Now, like I mentioned before, this is usually pretty quick. But at that first initial setup, when you're setting up your development environment for the first time, might take a minute or two just to get you set up so that you can you have everything you need to get working in your Codespace. And then finally, any configuration after that is applied. So this is your extensions. This is when, for any of you Python devs out there, this is when your virtual environment would get activated and things like that. So that's essentially how it works from beginning to end. So the last 3 steps, the container creation, connection, and configuration, happens when you open a Codespace that you already have. Okay, now moving on to a little bit around this customization piece. So essentially, like I mentioned, Docker, you have a Docker container that is configured for your environment. And essentially, this enables you to, this is essentially what enables you to essentially have the same development environment no matter what device you're working on. And you can essentially configure your Codespace in just 2 files. And the first one is going to be this devcontainer.json file. We'll see an example of that. This is where you would apply things like any particular extensions that you want applied, even any command line tools and things like that. And like things like formatters, anything like that, linters, that's where that would be. And then, of course, in your Docker file, this is where you might want to set a particular language version. So, for example, Python version, maybe the flavor of Linux you're using, and any other additional scripts you could apply here in your Docker file. Of course, you can use external scripts that your Docker file would reference. So anything that you essentially do in Docker, you could do here in your Codespace. Now, let's shift gears here a little bit to data engineering within a code space. There are quite a few things that you would do as a data engineer. This is not even an exhaustive list. This is a very condensed list. But some things that a data engineer will most likely work with or need are things like Python, a notebook, specifically a Jupyter notebook, SQL. So SQL for whatever relational data you might be working with. In addition to things like NoSQL skills. So if any of you are maybe working with MongoDB or Cosmos DB, you might be familiar with NoSQL or non-relational data. And again, those data sources. So relational data, usually from a relational database management system, non-relational and unstructured. So thinking about files, images, videos, those are considered data. So moving along, we have common tasks. So a common task that we will cover a little bit later is ETL, or extract, transform, and load. Extracting data from the source, transforming it and turning it into something else, analyzing it, and then doing things like streaming and pipeline creation. So in our demo, we're going to move on to doing ETL with GitHub in a GitHub Codespace. And in here, this repository here, you can go to the demo. So while I am setting up my demo here, Joe, do you want to talk a little bit about ETL?
Yes, I know. I've been trying to get a hold of you. Go answer the door. I got it from here.
Okay, thank you.
Yeah. All right. Well, first of all, that was super informative and amazing. Now we got like the what, right? Like we can use GitHub Codespaces to awesome overview of that too. But yeah, she's going to do a little demo. I might actually just like shift gears a little bit again and talk about like why you should care about this. And I'm curious if anyone in the chat wants to talk about their experience with data too, right? Like is there any data engineers in here? We all software engineers, we all like learning students, that sort of thing too. But I do want to just talk about like why you should care. So someone I follow, I saw this on Hacker News a while ago. They posted a little meta-analysis here that, let's see, it looks like her screen's up here. 70% of open roles at companies under Y Combinator are hiring data engineering as compared to data science. That means that there's 70% more data engineering positions open than data science positions, which is wild. And because I think the reason I say that is I think my understanding of like where people's interest is typically in the data science. And we're seeing that a lot too in the AI boom here too, with like AI, machine learning engineers, that sort of thing too. But why are more open positions for data engineering out there than for these data science and machine learning positions? I have a lot of theories about that personally, but I think the biggest thing that people sleep on, and this here is, let's see, an Askia. Maybe you want to put me full screen here. We can just close down Jasmine screen. Thank you. Is that to train massive models, machine learning and AI models, you need to have clean data. And it's a data engineer's job to make sure you're setting up the infrastructure and bringing in the data and then cleaning it up for whoever's using that, whether that's dashboards, machine learning models, internal, analytics, real-time analytics, whatever. The engineer's job is to set up the infrastructure, bring in the data, make sure it's clean, and then make it available to other teams to use, which can include all those other ones. And this is the dirty secret about a lot of engineering and AI positions right now, is that it's just a lot of manual human cleanup that's happening behind the scenes to make sure that the data models are going to work well for, whatever data they're being trained on or trained to do. Anyway, why should you care? Data engineering is huge. It's way bigger than anyone thinks, and it's only growing. And it's going to continue to grow as getting insights from massive amount of data becomes more and more important, which we're seeing that trend not going anywhere with the rise of like machine learning. Plain and simple. So data engineers, I love the term data engineering too, because it makes it clear that you need to have engineering skills in order to like work with the data. So you're working with like large data sets. You have to have a basic understanding of SQL, and then with SQL-based databases, RDBMSs, and different types of databases to work with. And then you're working with data pipelines and publishing the data from those pipelines for easy consumption. And it's going to continue to be an incredibly important role moving forward in the future. So, yeah, and I'm not saying it's going to like replace data science, machine learning stuff, right? Like these are positions that open up to work with each other. And I think as the field grows in the future, I think we're going to see a rise in more specialization happening in each of those subfields, which of course always happens. I know Jasmine's not here right now too, but I just want to mention that like with data engineering, we're seeing more like software engineering best practices emerging into the data space. And one of those things is like composability, repeatability, and like ease of setting things up and taking them down, which is where Codespaces actually works really well. I think we're going to see the rise of cloud-based development environments as we can make composable, even data environments. Can set easily blow up, destroy, and recreate databases in an instant using dev containers, and then developing them, which we'll show a little bit here today too. All right, cool. So great. I don't know. Is anyone in chat, is that resonating with anybody too? I'd love to hear your thoughts on that. But in my humble experience too, I understand that a lot of people here on this who might be joining us for this are probably going to be students or learners kind of jumping in, and you might have like a familiarity with what data engineering is, but you may not like know the details of how that works. If anyone's interested after this too, we can dig into like how to get into it. But I think a fundamental understanding of how SQL works and using SQL, I think, is super important. In my humble opinion, too, SQL's been around for forever and will be around for many more years. It's a really great evergreen skill to learn. Databases come and go, but SQL is almost forever. We'll see. We'll see how long forever is, but it's going to be a long time. Yeah, and then basic cloud skills are also going to be super important too, like including cloud-based development environments, which again are going to be huge. And Jasmine's back. Hello.
Hey, yeah, thank you so much for that, for covering that. Apologies.
No, that's great. Was it a package?
Yeah, it was a package. Yeah. So, but
I hope it's something good.
Yeah, it is. So
good. No worries. Yeah. No worries. I know I was like sitting in the backstage. Was like, oh my God, I have so many things to say. And you did a great job talking about Codespaces too. I know and you talked about the what, and I wanted to switch gears a little bit, talk about the why, to talk about like why Codespaces is super important and why development environments are super important, and why that's a valuable skill.
Yeah.
Yeah. And I don't know if you heard much, but we were just talking about like the basics of data engineering. And some of those like learning paths to get better at that too.
Yeah, definitely. And, we were talking about like, the evolution of data engineering and, as data engineers, like, you also are going to have a development environment. So things like, when we're thinking about the evolution of data engineering and development in general, to me, as someone, I'm biased to the cloud, but why not make it easier with things like Codespaces so that you can just get started as a data engineer? I mean,
100%.
Yeah.
And that's one of the hard parts with like getting started with data is like, it's hard to set up an environment locally and like repeatability. And that's where I think cloud containers is like a game changer for dealing with data, especially on a team. Like I can just send a dev container to somebody to set up our database environment. Like that's amazing. Because usually what happens in my experience with working in companies is it's some guy who's in charge of all the data and everything has to go through this person, and like it is just like a massive pain. And like, but the goal should be not to be pinned like bottlenecked by a single person. It should be like to make it super easy, which is where like these cloud-based dev environments become super important.
Yes.
In my humble opinion.
No, I'm with you. I
mean, I'm sure you're biased here too. But,
yes, we all are. But
we're all biased.
Yeah.
But hey, that's great. Okay, cool. Let's see here. I know you were just about to start your ETL demo.
Yeah, we can get right into it.
I guess I don't know. Want to show us like what maybe we can like dig into it too. I love having like a real example of like how to deal with data in the cloud. But yeah, Aska, do you want to pull up her screen and then I'll let me and keep me on too.
That's good. Yeah. And if anybody out there has any questions in the chat, feel free to ask. We are here. We can see your comments and we can see your questions. Yeah.
I like being featured while you're talking.
Okay, so let me just first off, let me just talk a little bit about what this demo is. So I'm just going to pull up the README here, and we're going to be doing some basic ETL. Let me just open up the Markdown preview, and so we can see this render.
Wait, can you explain what are we doing first?
Yeah, so we're doing ETL in GitHub Codespaces. So
what is ETL? Let's assume I don't know what ETL is.
Sure. So ETL is extract, transform, and load. And so what that essentially means is that it's a very common thing that data engineers are going to do, where they load data from usually one source or more. So this could be really, when you think about data, like I mentioned before, data can be relational, it could be non-relational, it could be unstructured, it could be semi-structured, like something like JSON. And so, one of the biggest challenges is first just like getting the data from these multiple sources and putting them in one spot. So things like, so when you think about things like ways to store multiple pieces of data or sources of data, you want to think about something like a data lake, which stores like different structured data. So in this demo, and then next is transform, and that's essentially taking the data and essentially converting it into something that is usable for your particular use case. So again, if you're working with different data types like structured, unstructured or relational data or non-relational, how are you able to kind of put that all together into a usable format for things like analysis or even setting up a machine learning model? So transformation is another piece of transformation is things like cleaning. One of the things that a lot of data scientists will joke about is a lot of their work is cleaning data. Data is what we call dirty, where it comes from different, it comes in different formats, comes in different things like, for example, when you're filling out a form, are you, if anybody based in the United States, we have abbreviated state names, or we have, or you can spell out the entire name. Or you can, even think about like if you put the abbreviation in, do you put like a period between each name? So for example, at New York, do you do N period Y or do you just do NY? And so, things like that are, ways that the data cannot be essentially have, not be the same format. So things like cleaning would fall under transformation as well. And then loading. So putting that data, the data that you've cleaned, the data that you have filtered out with the data that you need, putting it into its final resting place, or where the place that it'll be used for future use cases like analysis, or again, like making a model. So today we're going to be doing a little basic ETL demo here in GitHub Codespaces. We're going to be loading a CSV file with Python in Pandas. So let me just go ahead and open the notebook here. And as we know, let me open up the CSV file here. Let me just go ahead and do that. And I open up the CSV file here. What I have here is my CSV file. You notice that if you were to open this in something like Excel, this is going to look like tabular. So essentially look like a table. So airport ID and all these things would be essentially the header. And then all this data in here would be that information, each row. So how can I make this look like Cosmos DB item? So how can I convert that into something like this? This is something that a data engineer might have to work with, or a challenge they might have to overcome. So here I am in this notebook and I'm just going to kind of show you how you can do that. So just so if you want to follow along or do this yourself, you can of course jump into this repo and do these steps here. But essentially the first thing I'm doing is loading my CSV file. And so I load this using the pandas library, and I'm loading this into a data frame. So if I run this, the first thing it's going to ask me is my Python environment. So I'm actually going to go ahead and select my Python kernel, and I already have one here. So let me go ahead and select, I believe the one I had selected was 310. So I'm going to use that, and I'm going to close all this up here. Don't need my extension here, but let's go ahead and run this. And it's going to install a few things for me here. And while that's loading, let's take a look at our dev container. So as I mentioned before, here I am in VS Code in my dev container, and here is my dev container JSON file. Like I was mentioning before, notice that I have my version of Python, my dev environment, the extension that I'm using Python and PyLance. I also installed the Azure CLI here. So if I come down here and I do AZ, it takes a second to run. We'll see that the AZ prompts will be down here. So if I were to remove this, then it would be uninstalled essentially. So there's that. But now let's take a look at the Docker file. And again, this loads after I have my Codespace loads, and then the Docker file here runs after or runs when my Codespace is loading. So yeah, Joe, what do you think? Are we ready to give it a try in action?
Let's extract, transform, and load this data.
Let's do it. Great. Okay. So I'm going to go ahead and run my example here. Looks like I may be picking the wrong kernel. Let me select the right kernel here. Let's do that. So let's try. Oh, that's 10 was the one I used. Let's try 9. I think
Python environments are always
yes.
always tricky.
Yeah, let's see if this works here.
Fingers crossed.
Yeah, I worked. I switched to another browser, so
there you go.
Let's see. Yay! Okay. Woo! So recapping here, using the pandas library, I was able to load that airport CSV file that we looked at earlier, and I read from it. And what I did was I filtered down to airports in the United States. So if I were to get rid of this df query command here, I would just have all the airports. And it's quite a few airports in here. In fact, over 1,500 rows. So that's great. So we now load into a data frame, and now we're going to move on to transformation. So this is actually pretty easy to do in pandas. First thing I do is I'm actually just taking a small sample of my data here, and I use JSON on my my US airports variable that I created here, or my data frame that I created here, and I convert that data frame into JSON, and I orient it around each record, or essentially each row, so that when I run this, it looks like this. So the final step here was I just formatted the JSON here so it looks a little bit nicer instead of it all being on one line. So funny here, Port New Smyrna Beach, that's actually, I know where that is, that's in Florida. But some of these other ones, I don't know where they are, but that's our sample data here. So now let's take this JSON, this CSV that we converted into JSON, and go ahead and throw this into Cosmos DB. So for that, you need the Azure Cosmos library. And notice here that I have some secrets here that are located in my operating system environment. So this is an additional setting that you can add into your Codespace when you have a Codespace loaded up. You can actually go into your settings. You can also see this in the instructions in this repository. You can actually go into your settings and set up your secrets right there in your settings. And then you can import the OS library and be able to consume those secrets through here, through the environment variables that you created. So to essentially use the Cosmos DB API, all you really need is the endpoint and the key. That all gets created once you create your Cosmos DB account. My database name is demo. Here it's airport. And then I connect to my client. Next thing I do is I connect to my database. So this command called create database does not exist. It's pretty self-explanatory, but essentially, if your database is not there, it will create it for you, which is super nice in the SDK. Another thing here is my partition key, and this is just a key that you can use to essentially filter or organize your data. So one thing with Cosmos DB, it's really great for distributed data. You can distribute across different regions so that your data is closer to your customer or your users if you need to. I'm not going to get into that, but it's actually really interesting. Again, the database is where we store all of our containers, and container is essentially where the data lives. So essentially, a database and a container is a many-to-one relationship. And so let's take a look at what that looks like here in the Azure portal. So demo is my database, and airport is my my container. And I could actually come up here and add a new container if I wanted to, and then that container would just be in the database, or I could go ahead and add a new database. Okay, so final step here is I iterate through that JSON data. I give it a unique ID. And then I insert that data right into Cosmos DB in essentially 2 lines, which is really, really great. So let's go ahead and run this. So I'm going to go ahead and hit start, and looks like I'm missing looks like I might be missing a library here. So I'm gonna go ahead and install it. So, and I can just do it right here. Pip install you know what? This is the point where I believe I need to switch to my different environment. Let me just double check here. Let me make sure this all works. And let me just run it all. And let's just go ahead and reload this Codespace just to be super sure. So you can always we can always reload your Codespace, restart your Codespace. Codespace. Rebuild, full rebuild container, I believe. Yes, rebuild container, and let's see if we can get this working. And so essentially, the end result here is just taking those three CSV records and inserting them into Cosmos DB. So while that's loading, let's take a look at what we saw in the CSV file versus what we see in Cosmos DB. So essentially, what we knew as a column, right, in the CSV file now has turned into a key in Cosmos DB. And essentially, I like to think of Cosmos DB items, or what we call documents, as JSON. Another interesting thing that you can do is with the Nosql API in Cosmos DB, you can actually query this like SQL. So I can actually come here into my query editor and do just command here and hit F5. Oops, not F5. That refreshes.
Refresh.
Funny. Let's go and open this one more time. and where is the execute query button? Right there, right in my face. And there we go. And so you can actually do queries and filtering like you would do in SQL. So if any of you are familiar with relational database, SQL, MySQL, you can actually apply those same skills that you know here to Cosmos DB. So this is taking a second to load. So Joe, while this is loading, it can come back to me and we can while I troubleshoot, actually, this is taking a second to load. So if you want to go into what you have, I'd love to learn what you're building.
Yeah, and we always pull it back whenever. Also, your awesome demo. I have to say, I'm going to be doing some pulling from multiple data sources. It's a little. I think my version's a little easier. We'll see how it goes here.
All right.
We'll see how it goes. Not that it's a competition.
No.
But so first of all, I just want to say, like, I'm a developer advocate, data engineer, and software engineer, and I work for a company called Tinybird. If you've never heard of Tinybird before, no worries. But basically, we're just a company that allows you to build data products faster. We do three things really, really well. We allow you to unify different data. So exactly what Jasmine just showed you with pulling in multiple different data sources and then transforming them to like a more normalized thing. So the example today, we're just going to be taking in events from an HTTP client, which is a video game I wrote. But we can do things like pull things in from a data warehouse with a Kafka stream, transform that, and then output that. And you're writing that basically just with SQL. So you unify your data. You can transform that and develop data pipelines super easily using SQL. And then lastly, the thing that I think is the coolest is actually creating an API on top of those data transformations. Because, right, you get the data, cool, you got your data, but it's not useful unless it's easily shared. So I don't know about you, but I haven't set up an API server for, I don't know, probably 5 years. Everything I do is on serverless endpoints these days for just like publishing data or whatever. But we do those things really, really, really well. So anyway, Tinybird, we're built on top of ClickHouse. We're serverless and everything's SQL based. And we have a CLI and work through the browser. So, oh yeah, this is a fun example too. This is a real customer of ours. But they use, they're a massive e-commerce clothing retailer. And they use real-time shopping data from Kafka and combine that with historical data in Snowflake as well as product data that's kind of archived in Snowflake. And they're able to make real-time dashboards for, providing insights for whatever, buying and shipping and placement, all that stuff too. So it's a really great real-life example of why you'd want to pull in these different data sources, normalize them, and then publish out an API to use them. Okay, cool. So that's Tinybird. Check it out, tinybird.co if you want to. But should we? Is your demo working? Otherwise, I may just jump into my little thing here too.
Yeah, go ahead and jump in. My environment's still loading. I just want to make sure it's working in tip-top shape before we swap to me. So you can go ahead. You can do the honors. And funny enough, I can see that my score, I'm JG on there. I was playing around on it.
I just posted the link in the YouTube channel here. And let's see here. Maybe if you could pull that up on screen so people can share, have that. They're just streaming it, not looking at the comments. That'd be amazing. But I'm just going to give a quick demo. This is a tiny Flappy Bird. I've been working on this in my free time. If you're familiar with the game Flappy Bird, that was a big deal a couple of years ago. Cool. I just remade it in the browser. So we're going to, but my goal with this was to learn some data engineering by building a game analytics engine on top of it. So today we're going to be building a top 10 leaderboard and then also some individual player stats. And we'll be doing that using GitHub Codespaces as our development environment and then publishing those out in real time. So I think that's it. It'll be a quick little snappy thing. If anyone has any questions about this or wants to dig in, I also have the code up on GitHub if you want to check that out. It's all up there too. I'll post that on the chat here. So that should be pretty fun. Okay, great. Also, I'm going to play this again real fast. So I have to say, I made this a lot harder at first. I've nerfed it in the last couple of weeks. But it is... I wouldn't say it's as hard as Flappy Bird. it was, but we've decreased the difficulty by making the gaps a little bit larger in between the pipes. So, okay, cool. Leaderboard and player stats. Busted, but let's fix it. Let's see your code. So this is built on Phaser.js. Jasmine, have you ever used Phaser before?
Yes. Oh, it's so exciting.
It's been around for forever. I actually, to be honest, I wrote this game back in 2015. And then someone on my team was like, we're always coming up with bird puns because we're Tinybird's the name of our company that we work for. We're like, oh, Flappy Bird, Tiny Flappy Bird. Great, we should like do that. And I was like, oh my God, I got this thing already built. So it's Phaser.js. If you ever done like a game jam before, made a web app before, you've probably run across it. So, which is great, cool. So anyway, this is Phaser. My main thing, I just have 3 scenes I built here. The main game, the main menu where you sign in with your name, and then your end game. The main menu we added just to capture names, which makes it easier to kind of like categorize who's doing what and capture high scores and that sort of thing too, and get on the leaderboard. So great. The important thing with us too is like, I wanted to show real-time game stats, and we're going to do really simple things, but I think it's really fun if we have massive concurrent amount of data piping in. So if anyone is following along, awesome. I encourage you to go play the game so we can get some real-time stats to play with here too. All right, cool. So let's do a quick, I made this too small. So first of all, fun fact, we are actually loaded up in a Codespace down here in Visual Studio Code, the native version. Jasmine was in the browser-based version, but both work. So this is a little development environment on here. And Tinybird also has a Visual Studio Code extension. So any sort of extension that you use with Visual Studio Code will work out of the box with Codespaces, which is also cool in my humble opinion. And you can do things like set up, use a CLI, do anything basically you can do with the CLI straight from this thing. The other cool thing that I love messing around with is data flow, which basically gives you like a 3D or like a little map of all of your data sources and pipes and where they go and who uses what. This just kind of fun. But we're missing some stuff. I'm going to show you basically kind of like the schema of our data real fast. So I'm over here. This is our Tinybird dashboard. I'm keeping track of a couple different data sources. Deaths, and this gets recorded every single time your little bird dies. We basically capture the score that you get when you die, timestamp, and a session ID. And then I've been playing around with this other one called Sessions, and it basically just sends over an event every single time a pipe is created. And it allowed me to do some like unique data analysis on that and create these things called materialized views, which allows for like faster data analysis. All right, but yeah, maybe I'll show the code real fast of like what we're actually doing and where. So let's go back over here. So let's do like end game scene. I think I do this over here. I'm going to close this for just a moment. Send death. I feel like I tried to think of something that was less morbid, but I don't really know another way to describe a tiny bird dying in this game. So basically, when the end game scene gets created, right, this create method that's provided by Phaser, when that scene gets created in memory, it just invokes the function send death, and it sends a session and a score. And then we get some data back from our endpoint from Tinybird, which we'll show in just a moment. But I just want to show what this looks like. We have an event endpoint. And when we send the death, we're just sending data to Tinybird with a payload of data, which you can figure here. And it's just a simple post request. You could also hook this up, though, if you want to have a Kafka stream, Ably stream, like any sort of data stream, whatever. You can also be handling that, too. You can just pipe that data right in. For a web-based browser game, though, this was like the easiest, and probably, my humble opinion, most simple and best solution for this. So your browser's just going to be firing off HTTP post events with a authorization header, which is one of our tokens you get, just to make sure that not any Joe Schmo is sending over data to you. Okay, so anyway, we're just sending over HTTP requests every time someone dies with a score using Phaser. Nothing too fancy. And okay, let's see here. What are we doing? Oh yeah, let's go ahead and do a code. Let's do a code thing. So first thing I want to do is fix up our dashboard. Excuse me, our let's see here. So I'm going to do a npm, start. There we go. And open browser. Thank you, Visual Studio Code. And I know we're running out of time here, so we'll hopefully get this moving here. But where is? Oh, I found it. Great. I got like 40 browsers open over here. There we go. Okay. So let's do test. And our leaderboard is missing. And then you'll also notice if we die, our leaderboard is empty. Woohoo. So our goal here is to get both the leaderboards working and back in shape. And the way we're going to do that is by creating a pipe of some of the data we have. And we can actually do that all in the browser. So I'm going to do a, let's call this new file, call this like top and leaderboard.pipe. The pipes in Tinybird are what we call like our transformation loads. So this is basically we write some SQL that goes ahead and allows you to extract some data, and then you can publish an API on top of that query. So I'm just going to copy this. You might have to edit that. Great. And we have something called nodes. These are built on Python PyLibrary or PyLibraries. But it allows you to like write functional queries that can break up what you're querying and like makes it a little easier to debug and test and kind of write stuff. But we're going to write a node. This is a pretty simple one, so we're going to put it all in one. Let's just call it top 10 leaderboard, and then we'll just give it a little code on there. So, and we're going to write some SQL. And this is all built on top of ClickHouse. So all ClickHouse SQL works out of the box with this. But I'm going to select the name of the person and the score. Next, we're going to get that from the deaths data source, which should be over here. You can see the deaths. I always spell deaths with an L. Do you ever do that, Jasmine, where you like just consistently spell a word wrong forever?
Yeah, experience was mine.
Experience. Iron also weirdly for me. I can't explain it. My brain always gets flipped up. I'm like, I don't know. And like I before E is always meant, I don't know. Anyway, I spell death with an L every single time. And I can't explain it. Okay, great. And then I want to get the order by, oh, thank you, GitHub Copilot.
Yes.
Order by score descending. So that's going to get the highest score first and then descend it down. We're basically structuring our API request the way we want to get that data back. And then lastly, to get 10, you got to limit by 10. Done. Okay, so in my code space over here, what I'm going to do is do a, oops, I have to do this one works, TB push. This is going to push it up to my Tinybird instance in the cloud. So we'll test this out here. Great. Top 10 leaderboard is created. Let's go check that back over hither. I'm going to give us a refresh, see if that's up there. And pipes. Top 10 leaderboard. That's what we just did. So that's the pipe we just created. Hit run, and we got all that data back. Ooh, amazing. And then next, we just have to hit create API, or view API here, and it allows you to publish that. And I think actually, so that's published already. This might already be working. So I'm going to get this restarted again. Oops. I have a command npm ste is npm start locally that I always forget. It doesn't work in Codespaces because I haven't brought over my aliases. But let's refresh, and hopefully if this is working correctly, our leaderboard should be back in action. Woo! Which it is. And we should see it back here. I'm going to die real fast. This game has been me just playing a little bit to die to test out different states. And boom, our leaderboard is back in action over here as well. So we got a top 10 leaderboard, and we were able to pull these through. But if we want to do some like transformations too, we could pull things again from like Kafka streams. We could save this data over Snowflake. We could do a bunch of other crazy cool stuff in here too, which would be really fun. Okay, cool. Any questions so far? Anyone in the chat? Anyone wants to ask any questions? Go for it. I hope I didn't go too fast there too, but I have one more we could do. if you got time, which is player stats.
Ooh.
Yeah, so so like getting some generic data is really fun and cool, but I think especially with like game analytics engines, I'm like, I want to see what my stats are. I don't really care about everybody's, which is like interesting to see everybody's cool. But let's go ahead and make one that is just for you. So I'm going to do the same thing over here. What should we call it? Call this like player. Oops. Player stats. All right, cool. Dot pipe. We're going to make another pipe. And I'm just going to copy this boilerplate over here. Player stats. And we'll call this player stats. And if this works, we should see the player stats show up below on here. So right now it doesn't exist. Hopefully, if we publish something that works, fingers crossed, it'll work for us. So let's get back to it. We're going to write another query on here. So select. Also, can I just put this out here? I'm stuck at SQL. SQL is massive. It's been around forever. There's a million different flavors of it. It's hard. Pro tip, if you're new to this, workspace dependent, ChatGPT or like Microsoft branded variants of AI are also very good at writing SQL queries if you can give it a schema and kind of describe what you want, which can be really helpful for like getting into this and like helping kind of construct the queries, because I know that can be something block for people who are new.
Yeah, great point.
Anyways, it's been helpful for me.
Yeah.
But your mileage may vary. So, and always check to make sure it works. Don't blindly trust it, but it should be fun. So, okay. So I want to get the player stats. Let's get your max score. Let's get your average, and then maybe let's get like a running total. And then I want to see how many games you can get. So, or maybe let's just start with a couple. We can always add more. So max score. So this is from. You know what? Maybe it'll be easier if you like write what we're getting from deaths. And score is a field on death. So again, we can look back on here too. Cool little thing about the Tinybird extension is we just like see what the scheme is on here. We have a score, which is an int16 saved in our database. And I want to give it an alias as high score. Okay. And let's just do one more too. So average score, great. This is amazing. It's my job for me. What about some? Okay, sure. Let's do count. Count as, and I'm going to make one change here from what Copilot's telling me. I want to do distinct games with a distinct session ID. So session ID is basically like every time you start up a new game in the browser, it defines that as a new session ID as games played. And let's do some. I was wondering if it's, hey, there it goes. Hey, there it goes. Okay.
Wow.
Okay. And from deaths, great. Okay, this is the fun part. So I promised this to be about player stat. So we need to like figure out a way to get that on there. This is super cool. I actually just learned this too. But you could do, let's go here to a game stats. You can do things called dynamic parameters, and I think do I have one on here already? I might scores on leaderboard. No, not on this one, but that's okay. The dynamic parameters will basically allow you to pass in parameters via an API endpoint to change how the query works. So we can just pass in the name of the user right on there, and it'll modify the query in real time and pull that data back in real time too for us.
Cool.
I know, isn't that weird? Was like, oh, damn, that's a thing. So this is where we find the where clause to get the user, and we're going to find our dynamic parameter. We have this own templating engine. It's based on Python templating. If you ever used it before, it's pretty simple. So string, and we just have three parameters on here. We have name, description, and required. I think that's and default. Put these on here. So default, I'll do just my name, but it'll be that you don't put a parameter on there. Name equals name. Description. This is, what do we call this? This is like the name of the player you want stats for. And then required equals false. Okay, so it's not required. I think that's going to be good. Let's see here. I think that this is possible. Actually, with our code extension, I think we can just run the query in the browser in Codespace. I got too many windows up here. But let's try this. I think you can just highlight your query and then hit, is it Command Enter? Yes!
Yay! Oh, that's so awesome.
Okay, cool. So we're in Codespaces. This is our like shared development environment in the cloud. We're just working development local, or we're working in the cloud on this. This is not locally, even though it looks like it is. And it says here, forbidden player stats not found. Where the heck is player stats? Oh, I wonder if I haven't created it. I would have to push it up. So let's see here. I'm going to do the same thing I did before. Oops. Exit. We're going to just do a Tinybird push, and that should push it up to our environment. Oh, that's good. Red means red scary. I'm going to open up a browser here. I mean, it's not. It's fine. Bugs are a normal part of development, everybody, okay? Don't be scared. It's fine. And let's give it a refresh. Browse pipes, and let's see here. Do we see the top 10 leaderboard? No, it looks like it failed. That's okay. You know what I'm going to do is just do player stats. I'm just going to copy paste it in just for the sake of this thing. But just so you know, you can do this up here. Okay. And this, and oops. Make it pretty, and then let's run it. Hey, all right, I know it works up there now. So
great.
We got player stats. I'm going to create an API endpoint. We're going to choose that node. Boom, it's done. And I think that should work. So player stats.json, right? Let's find out.
Great.
So we're going to restart everything again, and then we'll be we should be rocking and rolling here. All right. Has anyone ever? I'm curious if anyone's ever built a gaming engine, because I've never done it before. But like obviously, just getting started with the basics of like the queries you're wanting, you can start expanding on those. I've written a bunch more, but still, it'd be because we do really well with like real time. Nope, that's not in there. So the other thing that could be wrong, that could have changed the name of the endpoint. So let's see here. Player stats. I'm going to go back over here. And I'm going to go to our scenes. Actually, it might be under our where we're sending the data in. Close that. Session score. Okay. Get data. Oh yeah, the URL. So that is on, I think, our main screen. Top 10 recent player stats. Nope. And great.
Live debugging, folks. Live debugging here.
Hey, you know, I love this too, because I think it's helpful to show people the blood, sweat, and tears that goes into this too.
Yes, absolutely.
Player stat. Oh, I think I called it player stats. So let's maybe go back here. Or maybe I can do let's change it up here. Player stats 0. Or so that's going to that endpoint. I don't know. I'm just going to refresh it here, see if that works. Or actually, maybe. Oh, there we go.
Oh, yay.
I just had to hit enter. That
awesome.
was, who knows? Anyway, now that like once the game starts, it goes and gets the player stats. It shows you your high score, combined score, and total games. So, and that was all just from our rinky-dink little query you wrote down here.
Amazing.
Okay, cool. So you can create more of these too, do whatever. But yeah, that's Tinybird. Do a bunch of cool stuff. I think that's it.
Cool. Awesome. Yeah, thanks so much, Joe.
Also, if anyone wants to do any, has any questions about building game engines or like anytime real-time data analytics or whatever, hit me up. I'd love to chat about it too. Also, if anyone's looking to like contribute to a project and like learn about data engineering, I'd love your help. I need help making this look pretty. I'd also love to add multiplayer someday, and I'd love to add some more game analytics in there too. So if anyone's interested, hit me up. I'd love to work with you.
Yeah, I will share the repository in the chat.
Amazing.
As well. Yeah, definitely hop in. It's open source. So if any of you are looking for your next projects or next open source project to work on, here you go.
Absolutely. And we got a couple, I know we're a couple minutes over here, Jasmine. I don't know if you want to talk about like the future, open up for Q&A, or we can just wrap it up here too.
Sure. Yeah. So, I think, I know we did a little bit of a speculation at the end or at the beginning, actually.
Yeah.
Like what
I got more. I
Oh.
was telling Jasmine, I love just wrapping up these streams with like making wild, bold speculations about the future. And mostly just for like, so they can be rolled back in the future and we can laugh at how wrong we are about our bold technology predictions.
So
who knows?
Would you like to share one of them?
Sure. Let's see here. What do we have here? I got something. I mean, obviously AI is going to be like changing things, machine learning, and like the use that data is going to make data engineering, and like machine learning engineers, I think, are going to be a growing skill set that gets needed to help clean up data sets to be used on large language models or using data from those models. Something I think is going to be interesting application of that is using machine learning algorithms on databases, and also doing, this might be a little wild, but like conversational analytics from that. So like asking your database with conversational text, like give me recent player stats, and it just producing that without having to write SQL, I think will be useful.
Yeah.
And in addition to, I mean, because your database is where the data is, like training a model on the data itself at the database level seems like a no-brainer to me.
Yes.
And it also, this is my dream as a software engineer. I'm not like, I don't really give a shit about the infrastructure. I just want to like put some data in. I want to get it back quickly and I don't want to worry about it too much. But if I could have like AI help run that, so like if it's seeing a lot of queries run hot on something or slow, it automatically adds an index or removes it if it's no longer needed, or makes recommendations about shard keys and like different things like that, or just does it for me, that would be my dream. I don't think we're there yet, but I feel like we're close, and I would love to see something like that in the future.
Yes. Yeah, we are definitely quite close, and like it'll be exciting to see that, those processes is like a lot more accessible to folks. These are I feel like some of these things are quite new, and like with any like new AI tool, like we're all still like trying to like grasp our hands, or like trying to understand like how to use it and how to really integrate it into our daily lives. So I think with things like data engineering, where we have there's so many tasks like ETL, just trying to get information from the data quickly, we're going to see a lot of evolution in the space. So
and like as developers, we're smart people, but like we still need things to be easy, and I think that the tools that are going to be easiest to use are going to win, and I think that AI can help make those tools easier and better for developers to scale and get started and grow professionally with. So who knows?
Absolutely.
We'll be shepherds to listening to our databases instead of maybe actively controlling every minute detail of them.
Right.
Which in my opinion sounds like a dream. So
it does. Yeah, for sure. Well, if nobody has any questions, I think we're here. We can wrap it up. Thanks so much for hanging out with us on a nice Friday. I hope everyone has some nice weekend plans. And Joe, do you have any final words to share with the audience before we get out of here?
I don't. I'm going to my family cabin right after this. I'm peacing out for the day. I am so thankful to be on here, Jasmine and Microsoft Reactor, everybody, and our producer. Thank you so much for like hanging out with us for a little bit, and anyone that popped in. If anyone wants to hang out with me, you can hang out with me at on Twitter or on Blue Sky or whatever. It's basically all this on my socials, so go ahead and look for me over there. But I'd love to chat about data, engineering, games, whatever. So I think that's it. Also, check out Tinybird. We have a free forever tier, which I forgot to mention. It's amazing. It's cool.
Awesome. Thank you all so much. And we'll share any resources that we have in our notes. And yeah, thank you all and have a great rest of your day, evening, morning, wherever it might be.
Woo!
Bye.
Bye.
Bye. All right. Thanks, everyone. Thanks, Joe. Thanks, Jasmine, for an awesome session. We are always looking for feedback. So if you have anything that you would like to add to the comments, feel free to use our Reactor survey slide or survey link in the slide, and you can give us some feedback that way. But thanks, everyone. Have a great weekend, and we'll see you next time.